Welcome back. Today we will be talking about the log functions and their graph. As you know, the exponential function of the form f of x is equal to a to the power of x passes through the horizontal line test, and therefore it has an inverse function. That inverse function is called log function, which we can read as log base a x if and only if x is equal to a to the power of y. So the basic functions remain the same as a to the power of x. In this case, we have log base 2, 8 is equal to 3. So logs are nothing but writing the exponential function in a different way. So 2 to the power of 3 is equal to 8. The same as 4 to the power of what will be 2. So 4 to the power of 1 half. 1 half is nothing but the radical of 4 will be 2. So the common log function, by default, we take it as with base 10. If nothing is written, it is log base 10. How to use it in the calculator is this way. So if you have to put f of x is equal to log x for x is equal to 1/5, I will first type it or press log, then bracket 1, then division sign, then 5, bracket closed, and then click enter. The properties of the log, these are very, very important properties. Please memorize them. Log base a of 1 is nothing but a 0 because anything to the power of 0 is 1. Anything to the power of 1 is the number itself, a. And number 3 is very, very important because the base is same and the number is same, so it cancels out. So a to the power of log base ax, a and log a, they are same. So they are inverses, so only x is left. So for in this example, we have 20 and log base 20. So they just vanishes away. So what is left? The answer is only 3. So property number 3 is quite important. Property number 1 and 2, they are just the same logic that you are aware about, that a number to the power of 0 is 1, a number to the power of 1 is the number itself. So another addition to the properties could be, you can say it is number 4. So if log base ax, log base a with y, then because both the log and has the same basis, I don't need this logs. We can just say x is equal to y, the same as the exponent property. So for example, we have log with base 5 and we have the number x squared plus 3 is equal to log base 5. We have a number as 12. So because both the logs, they have the same basis, I don't need them. What is left is x squared plus 3 is equal to 12. And from there, you can solve this equation and you will get x is equal to plus and minus 3. So the rhythm is the same as the exponential. The way to solve it, that remains almost the same. Now let's do a little bit of extension of it. So if I have to graph the log functions, because log functions, they are nothing but the inverse of exponential. So because it is inverse of the exponential, if I graph the exponential first, so first graph exponential, and then reverse the coordinate. That means then the coordinate will be f of x comma x. So we are switching x and y for log graph, and we are graphing keeping in mind y is equal to x. So what does that mean? So graph of log will be reflection of exponential graph in the line y is equal to x. So y is equal to x will work as the reflection line, and we are just reflecting y is equal to a to the power of x. That means the exponential graph over y is equal to x line. and that will be your log graph. So that is the easy and the simple way. So we are just reversing the x and y coordinate. Let's take one example. So let's say f of x is equal to 2 to the power of x, and the question is asking for to graph log base 2x. So if we have to graph the log function, let's graph the exponential function first. So let's make the simple x and y table 2 to the power of x. So we have x-axis, then we have f of x, which is nothing but 2 to the power of x. So I will just take bunch of x values. Let's take -1. 2 to the power of -1 will be nothing but 1/2. Then let's take 0. Anything to the power of 0 is 1. And then we can take one positive value as 1. That will be 2. So just a simple graph just to get the idea how the graph should look like. Because if you know how the parent graph looks like, and if you have a bunch of points, you know how the graph should look like, and it will be easier for you to join the points. So we will just make some points on the graph and let's plot them. So we graphed when x is -1, it will be 1/2, and 0, x is 0, and then x is 1. So we have 3 points, and I know it is a is positive, right? So it is a growth function. So this is how the growth function is. The base will be positive every single time, but the x is positive, right? Remember, a is always greater than 1, but x is greater than 1 as well, so it is a growth function. Now, for g of x, we are finding the inverse. That means we are just switching the x and y ordered. But we are doing the reflection in the line of y is equal to x. So new x will be f of x, and new y will be the x coordinate for the graph f of x. So new y will be nothing but the x from f of x graph. Let's just switch the order. So it will be 1/2, new x will be 1/2, and new y will be -1, new x is 1, then 0, and then 2 and 1. Now before I graph it, keep in mind we need to graph y is equal to x line as well. Y is equal to x line, it's very simple. If x is 1, y is 1, x is 0, y is 0, x is -1, y is -1, right? So the rhythm will remain the same. Let's try to graph the log function now. Now we have all the coordinates ready with us. We know it will be a reflection in y is equal to x line. Okay. Be careful when you are reversing the order. So this is how the graph will look like, and you can see it is a reflection, but one thing is missing. I need to graph y is equal to x line as well. Now it is up to you. You can graph y is equal to x line as the dotted line, or you can make just a solid line, whatever works for you. Just for your understanding, I'm making it as a solid line so that you can see how y is equal to x line should look like, and the log function, it is nothing but just a reflection of the exponential graph. So this is how you can graph all the log functions. And if there is any transformation related to the log function, the same thing will be taken care of. So first graph the exponential, and then change x and y, and that will be the rhythm of this. Now the another thing that we need to focus on in this unit will be characteristics of log base A x, where a is greater than 1. Remember, with the exponential function also, we are taking base as greater than 1. It cannot be 1, it cannot be 0. So domain is 0 to infinity, range is negative infinity to infinity, and the x-intercept will happen at 1 comma 0. And if you can compare with the exponential function, we are just reversing everything. And it is a continuous function because there is no interruption in the graph, there is no hole, there is no jump, nothing is there. When we are talking about the increasing function, and also it is a one-to-one function as well. That means it has an inverse. So what will be the inverse? You know it, and then the vertical asymptote will be y is equal to 0 or y, simply the y-axis, which is negative infinity as x approaches to 0 from the positive side, because that is how the parent function of log base a looks like. And another important thing is it is a reflection in y is equal to x line, and it is just the reflection of the y is equal to a to the power of x graph. So all these key points, if you understand these key points, then the graphing of the function log function would be quite easy. Okay. Now let's talk about something called natural logs. In the exponential graph, we talked about y is equal to a to the power of x, and then y is equal to e to the power of x. In this log, we are talking about the log base a, and then what will happen when we have the log with a different base, that is called e function. So log base e. So as we know, f of x is equal to e to the power of x is one-to-one function. It has an inverse. What is the inverse of log? What is the inverse of f of x is equal to e to the power of x? So there comes the log function with the base e. So the inverse of the function is called natural log, because I can write e to the power of x function in terms of log. And if you write in terms of log, log base e will come into the picture. So it is denoted by lnx. It is read as lnx. It is not in. It is read as lnel. It's pronounced as len as n of x. lnx. ln of x. So basically, f of x is equal to log base e x, which is nothing but ln of x, where x is greater than 0. So by default, log has the base of 10, but when the log has the base of e, that becomes natural log or ln of x. So they are inverses of each other, just like a to the power of x and log base ax, they are inverses of each other. Now, keeping this thing in mind, now we will see how the calculator can be used. So have your calculator ready. If you want, you can pause it and then follow along with it. So if we have a function f of x is equal to ln of x, and the question is asking for evaluate at x is equal to radical 3 minus 2. So how to plug it in the calculator? So first thing, you will hit ln tab on the calculator, then hit the bracket sign, then hit radical, then 3, then hit negative, then press 2, then hit bracket closed, and then finally click enter. So pause it, do do this way and see if you are able to get the answer. And this is how you will plug all the functions related to ln of x. It is a good idea to get yourself familiarized with your graphing calculator. So some of the properties that you need to keep in mind are as follows, and you will find a similarity with the other properties as well. So properties of natural log, number one would be, they are very, very important. If you plan to take calculus in college or in high school, then you will need these as well. So ln of 1 is always 0. The reason is e to the power of 0 will give you 1. So there's a reason behind all these properties. Ln of e, because they are inverses of each other, that is why it is just 1. E to the power of 1 is e, and ln of e is just 1. Ln times e to the power of x, they are inverses of each other, so it is nothing but x, and the same thing as e to the power of ln x. E and ln, they are inverses, we don't need them, only x is left because they are inverses of each other. Number 4, if ln of x is equal to ln of y, because both of them, they are the same ln's. I don't need ln. What is left? X is equal to y. So the properties of natural log, properties of exponential, they are somewhat the same. The approach is different. And this property is also called the one-to-one property. Let's take one example. Let's simplify 5 times ln of 1. Now look at the properties that we just listed. What is ln of 1? Ln of 1 is nothing but 0. So 5 times 0, anything times 0 is what? Just 0. So the answer is 0. As simple as that. So these are the properties, the natural log, and natural log is the first time that you are learning from this. I hope it made sense.